All right, today we're going to go underground. We're looking at a critical piece of engineering that honestly keeps our whole world running, but you'll probably never, ever see it. Trenchless pipe repair. And we're going to get right into the details on the one single variable that makes the difference between a perfect, long-lasting fix and a total failure. Okay, let's get into it.
So here's the plan. First, we'll talk about the big problem that's hiding right under our feet. Then we'll show you the really elegant, trenchless solution. After that, we'll break down exactly why pressure is the secret ingredient here, get into the precise numbers that engineers have to use, and finally, we'll wrap it all up with the key things you got to know to get the repair right every single time.
So here's the deal. Our entire world is built on this huge, invisible network of pipes. And over time, you know what happens? They crack, they break, they fail. Now, the old way to fix them, it was a nightmare. Digging these massive trenches, shutting down roads for weeks, just causing absolute chaos. It's disruptive, it's expensive, and it's messy. The old way just doesn't work anymore. So what's the smarter way?
Well, that smarter way is called a trenchless repair. And today we're zeroing in on one specific piece of tech, the Trelleborg DrainPacker. It is a truly ingenious way of fixing a damaged piece of pipe without ever needing a shovel.
The best way to think about this is like a medical stent, but for a city's arteries. So instead of replacing the entire pipe, a technician slides this flexible liner, it's basically a fiberglass mat that's been soaked in a special resin, right into the pipe. They position it over the bad spot, and then an inflatable device called a packer gets filled with air. This packer pushes that liner hard against the inside of the old pipe, and that pressure, well, that's the key to absolutely everything that happens next.
The success of this entire operation really comes down to just one thing: pressure. But not just any pressure. It has to be the right pressure, held for the right amount of time. This is what transforms that soft, resin-soaked mat into a new, rock-solid structural pipe inside the old one. You see, the goal here isn't just to plug a leak. As the official documents say, it's about creating a repair with structural integrity, which means it's strong enough to be a brand new pipe all by itself, and a tight, frictional fit. That just means there are zero gaps. It has to be a perfect, seamless bond, and it's the pressure that makes that happen. The process itself is very methodical. First, you get the liner into position. Second, you inflate the packer. But take a look at step 3. This is so important. The pressure isn't just a quick blast and you're done. No, it has to be maintained constantly and precisely for the entire time it takes for that resin to harden. If that pressure drops even a little, the whole repair could be a bust.
So, if maintaining the pressure is that important, then we've got to know the exact numbers. What are they? This isn't guesswork, right? This is precision engineering. Let's look at the specs.
This is the big question for any technician out on a job. How much air do you actually pump into that packer to get a perfect cure? If you go too low, you risk a weak bond. But if you go too high, you could actually damage the original pipe you're trying to fix.
The answer isn't just one number. It actually changes based on the size of the pipe you're working on. And the way it changes, well, it's a little counterintuitive. You'd probably think a bigger pipe needs more pressure, right? But let's look at the data.
So what's really fascinating here is the trend. Just look. For those smaller pipes in the 375 to 600 millimeter range, you need 25 psi. But as the pipe gets bigger, look down there at 900 millimeters, the pressure actually drops to 18 psi. Now that might seem totally backward, but it's all about total force. A bigger pipe has a way bigger surface area, so you actually need less pressure per square inch to get the same overall force you need for a solid bond.
So there it is. That's the key takeaway from the data. It's an inverse relationship. Bigger pipe, less pressure. Again, it's because that huge surface area on the bigger pipe means you don't have to push as hard at any single point to get that secure, uniform fit all the way around the repair.
And this chart just illustrates the point perfectly. On the left, you've got the smaller pipe, needs that higher 25 psi. On the right, the much larger pipe needs that noticeably lower 18 psi. It's just a fantastic visual that sums up that inverse relationship we were just talking about.
All right, let's bring all this home. We've talked about the problem, the solution, and the critical science behind the pressure. So what are the absolute must-remember rules for making sure this works?
Okay, so here are the big 3. First, you absolutely cannot use the same pressure for every job. You have to tailor it to the pipe's diameter. Second, this is not a quick blast of air. That exact pressure has to be held steady for the entire cure time. And finally, never forget why you're doing this, to create a brand new, super strong pipe with a perfect watertight fit.
And that pretty much wraps it up. It's just a great example of the incredible, invisible engineering that's happening all around us all the time. It really makes you wonder, what other complex, elegant solutions are working silently right under our feet just to keep our world running?